You know that feeling when time seems to fly by or just drag on forever? Well, what if I told you that's more than just a feeling? It turns out the steady second by second tick of a clock that we all take for granted, it's kind of an illusion. So let's dive in because time is way stranger and a whole lot more flexible than you can possibly imagine.
So let me just start by asking you this. Does a second right here on Earth last the exact same amount of time as a second on, say, a satellite orbiting high above us? Now, your gut might say, of course it does. But the universe has a much more interesting and honestly a pretty mind bending answer for us.
And to really get why, we need to talk about one guy, Albert Einstein. He just completely turned our understanding of the cosmos on its head. He showed us that space and time, well, they aren't two separate things at all. Nope, they're actually woven together into a single, unified fabric.
He called this incredible concept space-time. And the best way to think about it is as the very fabric of reality itself. It's not just empty space, It's this dynamic, almost physical stage where every single event in the history of the universe plays out.
Okay, so how does this fabric actually work? Just imagine you've got a big rubber sheet stretched out tight. Now, if you place a heavy bowling ball in the middle, what happens? It creates a dip, right? A curve. Well, in the exact same way, massive objects like planets and stars literally warp the fabric of space-time around them. And that warping, that is what we feel as gravity.
But this is where things get truly wild. See, this bend in space-time doesn't just change how things move through space, it actually has a profound and totally measurable effect on the flow of time itself.
And that brings us to our first major concept, gravitational time dilation. What it means is, the deeper you are inside a gravitational field, like us right here on the surface of the Earth, the more space-time is warped around you. And because of that, your clock literally ticks slower than a clock that's in a weaker gravitational field. Now, I know what you're thinking. This sounds super theoretical, right? Something out of a sci-fi movie. But what if I told you that you actually depend on this weird effect working perfectly every single day? Just think about the GPS satellites that are orbiting our planet right now. Because they're so far away from the Earth, they're in a much weaker gravitational field. And what does that mean? It means their clocks are literally ticking faster than our clocks are down here on the ground. And we're not just guessing here. The difference is incredibly precise. Every day, the clocks on those satellites get ahead of the clocks on Earth by exactly 38 microseconds. Now, that is a fantastically tiny amount of time. I get it. But it has absolutely enormous consequences. You see, if the engineers didn't constantly correct for this 38 microsecond difference, the entire GPS system would just fall apart. The map on your phone, it would become inaccurate by about 10 kilometers every single day. So the fact that your navigation actually works is daily, real-world proof that time runs at different speeds in different places. Wild, right? Okay, but the GPS story actually has another layer to it. We know that gravity makes the satellite clocks run faster, but those satellites are also moving incredibly fast at about 14,000 kilometers per hour. And it turns out, moving at high speeds also messes with time, but it does so in the opposite direction. This is the second piece of our cosmic puzzle. This brings us to our second key idea, velocity-time dilation. And it's actually pretty simple when you break it down. Your motion through space is tied to your motion through time. The faster you race through space, the slower you travel through time, at least compared to someone who's standing still. The most famous way to think about this is the twin paradox. So picture two identical twins. One stays on Earth, and the other one blasts off in a rocket traveling close to the speed of light. When that space twin finally comes back to Earth, they will have aged less than their sibling. They would literally be younger. And I have to say it again, this isn't a movie plot. It's a fundamental law of our reality. And of course, we've proven this beyond a shadow of a doubt. Scientists put these hyper-accurate atomic clocks on jets and just flew them around the world. And when they landed, those clocks were slightly behind the identical clocks they'd left on the ground by the exact amount that Einstein's equations predicted they would be. So, where does all this lead? Well, it leads us to the most extreme places you can possibly imagine: black holes. Near a black hole, gravity is so powerful that space-time is warped to an almost infinite degree.
time there, it slows to a crawl. An hour spent near a black hole could literally equal centuries for the rest of the universe. So let's just take a breath and pull all of this together. After all this, what is time really? The big takeaway here is this. Time is not some giant universal clock in the sky ticking away at the same rate for everybody, everywhere. No, it is a flexible physical part of our universe, a dimension that can be bent by gravity and stretched by speed. Your personal experience of time is totally unique to you, your location, and your journey through the cosmos. And that really leaves us with a fascinating final thought. We live our lives by the clock, right? We just assume that its passage is absolute, but we've just seen that it's one of the most flexible parts of our reality. So it really makes you wonder, if something as fundamental as time can bend and stretch, what other truths about our universe are just sitting there waiting to be shattered?